Hey guys, this morning we are picking back up. We're going to talk a little bit more about what we were doing last time, which was this idea of event loops and user interaction with programs. Specifically, we had been using an example where we had the user typing things in on the console or the command line, and then we were doing different things based on what they typed. And so we were using this function in Python called input, which waits for the user to type something and press enter, and then does something with what they type. And we ended yesterday after getting our program to basically work how we want. So if we type in add, it lets us enter two numbers, and then it adds the numbers, and we can also do subtract. And if we do subtract, it subtracts the second one from the first one. So 8 and 4 is 4. And then we can just exit, which will clear the, it will break out of the loop that we have here for our program, right? And so that's what we did yesterday. But the very last thing that we did yesterday was we had in our process here of testing this, try to enter something that was a string for a number. So nowhere do we tell the user that they have to actually enter like the number keys. So what happens if someone tries to pick add and then says they want to add the number 1? Well, you see, you can't do that because we are expecting here, when we're converting these things into variables to use in addition, we're expecting it to actually be an integer. And if it's not an integer, then our program just throws an angry red error message, and it doesn't do anything to handle that. It doesn't terminate gracefully, as they would say, or even better, it doesn't tell the user, sorry, you can't do that, try again, and then keep going. So those are more of the, that's more the user experience that we'd want here, because that's definitely better from the user's perspective. Because if you were to have this running on a server somewhere and your program ran into this problem, well, it actually stops. Like your program stops executing, and no one else would be able to use it then. And so that's really bad from an uptime perspective. Definitely not what we want here. And so today, what we're going to be talking about is how we can handle situations like this. Before we get too deep into things, I'm going to go over a couple different types of errors here. Errors or exceptions tend to be used pretty synonymously here. Python is what they call an interpreted language. Now, you may have heard that before. What that means is that the code that you see here in the file is not basically checked beforehand for, let me think about the best way to put this. It's not checked beforehand for like complete syntactic correctness in the same way that a file in C# is, or Java or C or other languages that are statically compiled rather than dynamically interpreted. Well, Python does have things that will check the syntax for you. So if you try to run a file and, let me give an example. So here, if we try to put that on a new line, you see how we get the red squiggles? We have something that's checking it for us. Probably it's either called a linter or just a syntax checker that's running in the background here. But if we try to run this, it's going to say that we have a syntax error. So this is the first kind of error that you can have. And usually these are the easiest to fix because unless it's something confusing, most of the time it's pretty straightforward to fix a syntax error. Like right here, you see it gives us the line number. It says it's line 591, and we're trying to assign something to nothing, basically, something that's not on the same line. So if we put the string back on the same line, well, you see that the red squiggles went away, and that's presumably because whatever program is running in the background to check the syntax here has noticed that, okay, now it's valid again. So we try to run now, well, then we run. So syntax errors, you might think errors are a bad thing. Errors are red, errors are scary. Errors are your friend, especially if they're good and descriptive, because they help you fix your code. Syntax errors are the first kind of errors, and you should actually want syntax errors because like I said, if all you have wrong with your code is syntax errors, you're kind of doing good, because usually they only take a minute to fix. The second type of errors is runtime errors. Now, runtime errors are what we have here. So we add, like we're running our program, we're executing things as we're supposed to, and then in the process of running, you get a big red error message. So your program runs okay. Basically, it has valid syntax. The statements that you're making aren't illegal in the way that you're making them. However, during the course of your program running, an error gets thrown and you don't handle it. Those are runtime errors. And then those are the two types of errors that will throw red error messages: syntax errors, which I already mentioned, and runtime errors. Now, there's a third kind of error. These are, confusingly, these are the most difficult kind to catch. So here's an example. Let's say that we mistyped this function so that rather than being num1 plus num2, what if we made it num1 plus num1, right? You see, that would be a typo, that'd be a mistake. However, if we run this, it's still going to let us run okay. There's nothing illegal in terms of writing code about this, right? You can add two numbers here. You can even have an unused argument in your function. There's nothing illegal about that. And as we'll see, if we add this and then we do, let's say we add the numbers 5 and 7, we'd expect the addition of 5 and 7 to be 12, but what we're going to get is 10. And of course, it's obviously going to be 10 because we're adding the first number twice. However, if you're going through your code and you're trying to figure out, hey, I added 5 and 7, why isn't my result 12? I don't know. Do you know? Like, there's no obvious way for you to figure out, why is my code wrong? Like, what line is it wrong on? You have no idea. These are by far the hardest kind of error to catch. These are called logic errors. It's where your code just does the wrong thing. However, it doesn't do anything illegal, and it doesn't throw any exceptions during runtime that you get a line number and a stack trace for. So logic errors are the devil. You do not want logic errors because logic errors are very, very hard to track down. And I can give you this one, kind of easy and contrived. Let me give you one that stumped me for a while. I had a project in college where we had something like, I don't even remember the exact context, but we had like a list of things where, I don't know, let's just make it numbers for now. And I was using a for loop somewhere to go through the list, and I'll get to why I'm bringing this up in just a second. I had a for loop for things in the list where I was trying to remember the exact specifics here. Basically, I was iterating through the list, and if a condition was met, I was like removing the thing. The problem is that the things that I was iterating over, they kept changing as I was going through the list. So I would be, going over a list of okay, you know what it was? This was a for loop in a different language, so not Python. It wasn't a for each loop. It was a for loop with indices here. And every time I removed something from the list, all of the indices changed. And so I would get this behavior that just wasn't right whatsoever, because I'd be going through these numbers. I think I might have actually got out of bounds exceptions as well. But the point is that I certainly wasn't getting the right behavior. But everything that I'm doing here, it seems like this is, like something that you might want to do, right? Like you might want to loop through a list, and if something's true, you might want to remove things from the list, right? Like if you want to remove duplicates, for example, or you want to remove numbers that are like higher than a certain threshold or lower than a certain threshold. Like this is definitely something that you might want to do. But the problem is that the way in which I was doing it, where I was removing something while going over the indices in the list, I'm changing the same object. So I was removing the list while I was iterating over it. or sorry, changing the list while I was iterating over it, like changing indices in it,
Mm-hmm.
boy, I think that actually took me more than a day to find. Like, and by day, I mean, like I spent hours trying to figure out what was wrong with my code. And of course, this was back in college when I wasn't probably quite as quick on the uptake as, later. But this is the example. This is the sort of error that you really, really don't want. Because if your code compiles okay, even if it runs okay, and you just get the wrong thing, it's really, really, really hard to find what you did wrong. Usually, by the way, the best way is to get someone else to look at it. Now, in college, unfortunately, this is very frowned upon. They have academic dishonesty and all of this, and so they basically say, no, you can't look at other people's code. Looking at other people's code is synonymous with cheating. Now, okay, that is what it is. I kind of understand. There's like, the educational rules in place so that people are academically honest and degrees mean something. And, being that as it may, the thing is, in the real world, if you get hyper stuck and you're like, my code isn't doing the right thing, like I don't have any errors, it doesn't have any syntax errors, doesn't have any runtime errors, it's just not doing the right thing. And you look at it for a couple hours and you Google around and you can't figure out what you're doing wrong, you will 100% ask a coworker, hey, can you just look at this and tell me if I'm being dumb? Because like sometimes they'll be like, why are you doing this? Because they're not you. Somehow in your brain, what you did makes sense. However, as a third party who's more impartial and objective, they can just be like, what's this supposed to do? That doesn't make any sense. Like they'll ask questions like that. Now, if they're kind, usually they won't rub it in, because we all have occasional moments where we're like this, where we did something and it made sense in our head. And then, like someone else will point it out and you're like scratching your head and like, I have no idea why I did that. That's really dumb. But in the real world, you will 100% ask someone to look at your code, because it is by far the fastest way. If something is truly wrong, you have a logic error, you don't know where it is. The other thing, sometimes, unfortunately, you don't have someone next to you. You don't have someone next to you to look over your shoulder. So there's this practice called rubber ducky programming, where rubber duck debugging. Here, Wikipedia article. So it's a method of debugging code by articulating a problem in spoken or written natural language. So basically, there's this anecdote where a programmer would carry around a rubber duck and then debug their code by forcing themselves to explain it line by line to the duck, right? So the benefit of this particular approach is that you don't even have to have a human here. You just need to explain out loud. I mean, not out loud, you can do it in your head too, I suppose. But you need to go through your code line by line and say, what's this doing? What's this doing? What's this doing? And the practice of going through like this. By the way, this is exactly why usually if you grab someone and you try to explain your code to them, because normally you don't just say, here, look at my code and expect them to figure it out. You try to explain it to them. A lot of the times you'll fix your own problem. And in fact, it can be really annoying when you're like a more experienced developer, because what will happen is all the junior guys, they'll grab you and be like, oh, Steven, I'm so stuck. Come help me. And then you'll stand there behind them and they'll start explaining it to you. And then they'll be like, oh, okay, I got it. And then you're like, wait, I thought you were stuck. Like, why'd you come get me from my desk? Why'd you interrupt everything I was doing? The answer already, yeah. Right? But it actually happens a lot, right? And it's not their fault. It's like legit, because in the process of trying to explain it to someone else, they figure out exactly what's wrong. So it's great to be able to, figure it out without having to interrupt someone else's workday, though. And so just get in the habit of, I know I'm kind of throwing a lot at you. This is exception handling, dealing with errors as a programmer, debugging. This is all just core fundamental stuff. So it's why I'm going on this tangent a little bit, because it's really important. Like for you to be able to make the most rapid progress as a programmer, you need to get really, really good at figuring out what's wrong. And so, like I said, I want to emphasize the point. When you're first starting to program, you really don't want to see red. You really don't want to, oops, this one is dead. You really don't want to see error messages like this. However, once you've programmed a while, you want to see error messages like this. And what you don't want is for your program just not to do the right thing, because those are the really tricky ones to track down. Everything we've said makes sense?
Perfect sense.
Also, like I said, don't be me. Don't try to remove things from a list when you're iterating over it. Very hard to find. So, all right. So now we're going to pick up, and with that introduction, of the three kinds of errors. So syntax error, your program doesn't even run. Runtime error, your program runs, but randomly craps out somewhere because an error is thrown. And logic error, which is your program runs and there's no errors, but it just doesn't do the right thing. Which kind of error is this one that we've been seeing?
Runtime error.
Runtime error, right. And so runtime errors are the ones where you can fix it by handling them in your code. So you can't fix syntax errors with code because well, actually you can, but I mean, the whole point of syntax errors is that you like messed up in how you wrote something. Like you didn't close parentheses for something, or you didn't like match a string, so you only have an opening quote for a string and not a closing one, or something like that, right? Something silly, something easy. Runtime errors are the ones where you are actually throwing an error, but it's blocking execution of code because it's not being handled. So for our purposes, runtime errors are really the interesting ones for us, because if you can come up with every case in which your code would throw a runtime error and you say, hey, if it does this, then do this, then suddenly your code won't stop anymore. It won't get blocked in this way. And so for us here, we know that the thing that's causing us to have an error is when we try to enter a string for one of the numbers rather than a number, right? So one good principle of design, I know I kind of harped a little bit on user interface design yesterday and how we want to be giving them prompts and stuff so that it's obvious. Here, probably what we would want to say is enter two numbers as digits, right? If we say that, well, suddenly, even if we don't handle the problem in the code, then when they press this, they're going to know as digits means, oh, I need to actually put a number. It can't be a string, right? And then they do it, and then it works fine, right? So, you know, one of the best defenses you can have against having your code be brittle is to give very clear and explicit instructions. Unfortunately, a lot of the times, the people using your program aren't going to be programmers themselves. So you don't want to ever include the Y here. You don't want to only include, you don't want to say enter two numbers as digits, because in the process of casting from string to integer, if it's not a digit, a runtime error occurs. Don't write that, because the user is going to make a very confused look and have no idea what that means. And then all you want to do is give instructions. I mean, you want to try not to be super arbitrary about it. Like this one makes sense, right? Because if you're entering numbers as digits, that's not so onerous, right? But you know, usually you want to program your code in such a way that even if it makes you do extra work, even if you have to process things more or whatever, you want it to be as obvious and intuitive as possible for whoever's using it. Because guess what? You can do the extra work to parse what they do more, or to, I don't know, check it or process it or whatever. But the second you start making it harder for your user to do stuff, just expect pain and suffering to follow. So I remember I was saying not very complimentary things about users yesterday. Well, that is just what you need to keep in your head. In production environments, in the real world, they're the ones paying you to write the thing. And it doesn't matter if they're being silly and they're not following things that should be common sense and whatever, because they're the ones who are controlling your salary. And so for the most part, even though users make a lot of silly mistakes and they try things that are like, why would you ever do that? That doesn't make any sense. You still have to handle it because it's your job. And the other thing that helps and makes you want to like stab them in the back less is that none of them do it intentionally. Like they're not being intentionally dumb and trying to break your code. Like they're not sitting there like, let's see all the situations in which we can like mess this up. It just is fact of life. So you get used to it after a while as a programmer. You get used to the fact that, you know, it's just your responsibility to make your code robust, because somehow, somewhere, someone will try to break it no matter what you do. And so you need to make sure it just can't be broken. That is basically the standard that you need to hold yourself to when you write code. Because if you don't do that, sometime someone's going to try to do something, even though it seems like it's common sense that you shouldn't do it, well, they're going to try to do it anyway.
Yeah.
I think I'm just kind of rehashing what I said yesterday, but at any rate, this is why the best solution is to give good instructions so that it's harder for the user to mess things up. Like I said, just because we give good instructions that are obvious like this doesn't mean that they're not going to do it though, right?
Yeah.
Okay, so you see, now it says that we have this message that tells them to enter numbers as digits. Okay, so that they enter numbers as digits and everything works, great. However, even despite this, someone might still try. You see that we didn't do anything in our code to handle this. You still have the problem, just less likely for the users to make the problem now. Okay, so we didn't get around the fundamental problem, but this is always step one. Step one is always making it better, making it easier for the user to understand, because even if we handle it, as you'll see later, even if we handle it, it's still annoying for the user if they enter a number and then get told it's not the right thing to do. Well, if it's not the right thing to do, why didn't you tell me it's not the right thing to do, right? We want to be clear in the instructions we give them. But we still need to be able to terminate gracefully. So it's actually been a while since I've written Python try-catch blocks. So Python's not strongly typed. It doesn't have data types like C# and C++ and Java and stuff. And so I write C# a lot in my job. I also TypeScript, which is like strongly typed JavaScript. So what I am not sure is whether Python has actual classes of exceptions that you catch. So let's not go to the main docs. I think I mentioned this before in the course of this series here. Main Python docs are great once you're an experienced developer and you just want to know like what the inputs and outputs and basic stuff is, but it doesn't really like, what's the best way to put this? It kind of assumes knowledge, right? Like it assumes knowledge and stuff. And so if you don't have some of the knowledge that it assumes, it's not going to sit there and define anything for you. And it's not like all websites are universally bad or W3 schools. Like I said, I've used this one a lot for HTML and CSS and stuff. Usually has the nice examples that you can just try on your own. Okay, so it does look like Python lets you catch specific kinds of errors, which is good because sometimes you want to handle different kinds of errors differently. I mean, actually, I'd be shocked if it didn't let you, but I just didn't know how it worked because it's been a while since I've done it in Python. Okay. So you may see this syntax here. We can actually throw our own exceptions as well. This has some benefits for kind of code readability, maintainability in general. For example, I've mentioned before that something I've worked on at work is like the user uploading a file and then we import it. So it's like an Excel file, has some data in it. Well, what happens if they give you a file that's empty, right? Kind of makes sense for you to show them an error message because you say, hey, you know, if you want us to import this, it has to have stuff in it, right? That's a case where right now in our code, we are throwing an exception. Now you could also not throw an error. You could just return like an error code or something, you know, a string that says error or whatever. But, you know, I don't want to get into all the technical specifics. One of the advisors on a project actually is trying to get us to move away from throwing exceptions for everything, even though it makes the code kind of easy to understand, because exceptions in execution are actually expensive. Like they take resource time. They, you know, like they have to get logged, blah, blah, blah. I won't get into the nasty technical details, but just keep in the back of your head that you can throw exceptions too. A lot of the times, the ones that we catch are things that we can expect, we can anticipate beforehand, but it's also possible for us to do it. So in Python, it's called raising them, I guess. Many other programming languages use the keyword throw here. But raise here is the ability that we have to put an exception ourselves. Okay, so general syntax for exception handling. You use here, I guess it's not called try catch. Try catch is that's at least Java and C#. It's try except in Python. So basically what you're going to do is you're going to try to do something. This is the syntax. You're going to put it in a code block. So it has a colon and you indent everything underneath it, just like other blocks. So you're going to try to put it in a code block here. And then if an exception occurs, then you're going to do whatever this is. And now if you catch it when the exception occurs, then it won't stop execution of everything else. So without the try block, the program will crash, right? That's what we've been seeing. The red error message to the console and stopped execution, and you can't do anything. But with when you wrap things into try catch, suddenly you get to determine what happens when an error occurs. Now Python lets you do other stuff with, like if there's no error, you can put like an else, just like an if. But in general, again, I think I mentioned this with other things. Python might let you do this. A lot of other programming languages don't. And so if you're trying to make code that is more understandable to a wider group of people, I would just stick with try and accept for the most part. Some Python purists might take issue and say, well, why aren't you using everything the language has to offer? And quite simply, it's because suddenly then your try-catch statements don't look like try-catch statements in all the other programming languages. And it's really confusing for people who aren't familiar with it. And every single programming language, many of them actually have a finally as well, but whatever, we're just not going to talk about it because we don't need to. Most things you can do with this, you can also do with just try and accept. So I don't know. Maybe I'm being a little bit of an elitist here, but in any case, all programming languages basically let you do what we're going to talk about now. This is very, very common. It's something that you're going to need to get used to. Specifically, this idea here of handling different errors differently. Something that we will do at some other point is we're going to implement division, and I will show you that we'll have two different kinds of errors when we do division. So for the time being, we are going to go back to our program here, and we now have the knowledge armed with this here to put this in a try block. So we're going to say, we're going to try to do this. We're going to try to cast this to an integer when we get it. And then if we can't do that because they didn't give us something that is castable to an integer, what do you think we should do? Should we just ignore it? Or should we somehow tell the user that this has happened?
We should tell them that something happened.
And this is kind of a I don't want to say common mistake that people make, but if an exception happens, it happened, you might log it, right? So you might have a log for your application of all the exceptions that have been thrown, so that you can go back if someone calls you in your help desk and says, hey, I was doing this and this and this, and then something happened and I couldn't access my profile, or I got an angry red text on the screen or whatever, then you can go back and say, oh, well, when were you doing this? Well, I was doing this around such and such time, and here's my user ID or whatever. And then you'll go in and say, okay, look, here in the system logs, we have logged that an exception was thrown from this person's blah, blah, blah. You get the idea. However, if you don't tell them that an exception occurred when they try to do something, if you just tell them, like if the page just sits there and spins, or I don't know, something else that's really bad. I know I keep going off on rabbit trails here, but we've had some issues with this on my team, but we've had to think about it a little bit. Is if you just give them a really generic error message, like in this particular case, let's say that beginning programmers sometimes try to be lazy and they do something like this. So rather than having an error message that explains what caused the current issue, what they'll do is they'll just kind of be general about it. An error occurred, please try again, right? So if we do this now, what you'll see is that, let me actually line on the end of that too. If we do this again, we'll see that now we can do add. And for the first one, that's the only one that we've tried and accepted here. Well, am I doing that? No, I was doing that in subtract. Whoops. You see the problem? This right here is inside of subtract, and I thought it was in add. So I was like, why isn't it working? Oh no. Oops. I did add again out of habit. Let's do subtract here. Okay, so now we're going to try this one. This one, we don't expect an error now. We expect it to get handled and we expect it to print out the other thing. An error occurred. Please try again. Right?
Yes.
Okay. So, but you see how we moved on to number 2?
Yes.
Right?
Yes, I see. So it should have taken us back to number 1, and it says it did try to do a subtraction.
So if you said it should have taken us back, what exactly do you mean by that?
We should have gone back to number 1, requiring input for number 1.
Now, should we have gone back to requiring input that they pick, add, or subtract?
No, just to entering a number for number 1.
Okay. So do you want to tell me, how do you think we should do that? So if we want to try for the person to do this, and then if it doesn't work, we want to go back to something, what does that sound like to you?
It sounds like a for loop.
Okay. I don't think for loop so much, because we don't really know how many times we need to try, right?
Yes,
we want to try until we get it right.
Loop more.
Yeah.
Yes. A while loop more.
Okay. So at any rate, you see how this is working, right? Actually, we don't need that new line. So we didn't actually get an error for this one, but it also didn't let them go back and do the right thing. However, really the point that I was making leading into this, we will fix this so that we try it and we do it appropriately in just a second. The point I was making was that when they enter this string, and the actual error is you can't convert a string to an integer, right? But what we tell them is an error occurred. How are they supposed to know that the error is caused by them trying to input a string, not a digit? Like, we don't tell them that, right? And if you don't tell users what the actual problem is, how are they supposed to fix it? So this is called bad user experience, or bad UX. You'll see user experience abbreviated to UX and user interface abbreviated to UI. Now, in a lot of really big corporations and stuff, they have like separate teams for this. They'll have like the design people, they'll have the designers and the user experience experts or whatever. Yeah, I guess my team's not big enough, so we have to wear many hats. What it means is that we're full stack web developers. We do the back end, we do the front end, we do CSS, we do everything. I mean, mind you, we have a different team, so people do specialize a little bit, but in general, we're responsible for designing the interface of our own applications. We don't have a separate design guy who does it. And so we have to think about stuff like this, about, if an error pops up and we need to inform the user what they did wrong so they cannot do it wrong again, what do we tell them? And like I said, you're not going to want to be like, during the cast from an integer from the string, blah, 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 blah. The user's not going to know what a cast is. They're not going to know what data types are. And so what you need to tell them isn't, you don't want to use any programmery language, is what I'm saying. If you have programmery language in your error messages, users are going to be confused. And so what you need to tell them is what happened, except in like, is that insulting if I say normie language? You need to use normie language.
No, it isn't. It makes sense.
You need to use the language that natural, like people who aren't programmers will understand. And so here we want to say the number you enter must be a digit, not the written. Okay, so now we're actually going to come down here and we're going to do the same thing for this one. So that needs to be num2. So if we run this again, so we know that we're doing subtract, not add here. If we do now, you see that at least our good error message is coming, right? The number you enter must be a digit, not the written out form. Please try again. So now it's clear, at least, that we're not crashing inelegantly, but we're also telling the user why something is wrong so that they know not to do it again in the future.
Yeah.
Okay. So you see, now we have two variables, and we try to do something with both of them. And so we actually got a runtime error here. This is still because
it can't execute the code at that point. It tries to the strings from each other.
Yeah, and I think it's because these are only defined in local scope. See, I was actually kind of curious. Sometimes programming languages let you be a little bit lazy, and if you wrap something, it might allow it to be defined outside of this try block, right? Like down here, down underneath it. So I guess one question that makes this simpler is: do we need different try catches for these two cases, or is the same error for both? Right?
It's the same error. So
so if we move it all into the same thing, then we don't really care whether they mess up on number 1 or number 2, right? We're going to tell them the same message, right? So we can get rid of 2 try catches. Now I'll actually look into the definition of statements and stuff. Now, this statement doesn't really need to be in the try catch because it's external to it. Now, even so, you might want to group it so that it's not like orphaned off on its own, right?
Okay.
So here what we're doing is the user picks subtract. We tell them that they picked subtract, right? So they know what's going on. And then we're going to try to have them enter the numbers. And we're going to try to grab the numbers as input. But if the numbers aren't input, well, we're going to tell them so. Okay, so that is what we're going to try now. So subtract and then 1 Witten. Okay, so we're not getting around the fundamental issue here. Okay, I see actually. Now we have the problem of we're running into that problem that we're not trying again here. So as soon as we had this exception from number 1, we went to this part of the code, the except, and then, like after we printed this message, we tried to go straight here, but it hasn't been defined yet, right? You know what? Let me actually, hopefully I'm not going to confuse you greatly. Let me go back, and I think I know why now. I don't think it's actually the issue that I thought it was initially with the, like basically with it not being defined in the scope. Okay, I don't want to go that far back. But let's split it again. Because I think the issue was, and I apologize, brain's a little bit slow on the uptake here in the morning. So hopefully this won't be too confusing. Okay, so now we have both statements wrapped in try catches, right?
Yes.
And so this is why when we run it this way, because they're separate, when we do the subtraction, well, the first one, once we hit 1, what we did was we got right there. Actually, for spacing wise, I'll say that. Once we got here, this code executed in place of this. And once we get here, we'll see if we do the other one as well. Well, that's after we get this. You see, we printed this error message. So what happened both times is we didn't actually define a value for the variable because this part was where it errored. That's why we're getting this, not because it can't see num1 and num2. That's what I thought might be the case initially, that because these things are defined inside of a block, that the external scope can't actually see it. I don't think that's the case because, well, I'm pretty sure that the reason why we're getting this particular error is because we didn't assign it, because instead of assigning it, we got this. I mean, we'll test my theory in a second here. So what we want to do then is we want to basically, rather than having the blocks like this, So I was doing this just to show you, just to get it through your head that it wasn't that we got an error immediately after. It's that if we have two separate try blocks, when this one fails, this message gets printed. And when this one fails, this message gets printed. But we actually went on to the second one, right? We didn't sit there and wait for them to get the first one right, which is not what we want.
Yeah.
So I'm going to show you two ways of doing this. Now, do you think it's better to wait for them to get the first one right before they do the second one? Like, let's say that they enter something valid for the first one, but then they mess up on the second one. Do you think it's better to only have them redo the second one or to try to also redo the first one? See what I'm saying? Like, you know, let me type it out. I think it'll make more sense. What I'm saying will make more sense in a second if I just show you exactly what I mean. Okay, so let's say we try to handle the errors at the same time. This is why I switched back to 2, by the way. Let's say we try to handle the errors at the same time. So are you okay if I just write out the loop to check this? Or
yeah, I am.
Okay.
I'll just go.
So think about this. Okay, here's one way to do it. So we're just gonna have a loop here where we go until they get it right, basically. So usually infinite loops, not a good thing, right? But this is what we're gonna do because we can manually specify things with break and continue. Remember us using break and continue? So if we do everything in one, then what we're gonna be saying is we want to do all of the things here in the same block. Okay, so we're going to get the two numbers in the same try catch. Actually, I think we can do it in one. You know what? I think I was not speaking correctly. So what we're going to do is if we get to the end of having gotten both numbers and no exceptions were thrown, we're going to break. That means that we now have the right stuff. We don't need to be in the loop anymore. And every time we throw an exception, we're going to continue. We're just going to go try the loop again, right?
Okay.
Will this do what I want? No, maybe it won't. I actually have to run it and get it in my head, you know. But oops, line 640. Oh, this needs to be indented. See the problem? This is at the same indentation level. It's not nested. So we have an elif, and then it's on the same level as an elif down there. So I just messed up the indentation there. There. Now it should go. Okay, so now we're still in subtract, so we need to be testing subtract here. So let's say we get the first one right, but we mess up on the second one. See how we have to enter the first one again?
Yes.
Is that what we want, do you think?
No, we just want them to fix the one that's correct. That's wrong, sorry.
Yeah, exactly. And so this is why I went back to splitting them. I wanted to make sure that I wasn't misleading you. This is why I split them again with the separate try catches. Because if we do it all in one here, well, you see that at least now our program is robust, right? Like you see now, at least we're telling them to do it again. So if we fail on the first one like this, well, then it starts from number one. It always starts from number one though. Right, they have to enter both again.
Yes.
And then if it does that, it's valid, right? Well, 6 minus 7 is -1. That's correct. Does it make sense?
Yes, it does.
Okay.
So you split the try blocks again now.
I will. And so we'll have the same structure with the while loop for both of them. So we're going to do the exact same validation for both. It's just that we actually need to do it separately. That way, they only have to re-enter the one that's actually bad. So this was where we had it combined up here. So we're just going to do this, and we're going to do it twice. So we break if it's correct, and we continue otherwise. If it's correct, and we continue otherwise. Except this needs to be. Right? Does my indentation look right?
Yeah,
No.
the first one is not indented correctly.
Okay. So I think we have indentation right now. We've got the break and the continue and the break and the continue. Okay, now let's try. So we're still doing subtract. And we're gonna again try to do subtraction. And we're gonna do an error. Well, let's do this one first. The first case is the one, and now let's try to mess up on the second one. Haha. See how we're still just on the second one? So we can mess up as many times as we want on the second one. And as soon as we press a number, it will do it.
Right.
And if we mess up on the first one, again, well, we want it to just be the first one, right? So still first one, still first one. As soon as we enter a valid one for the first one, we move on to the second one. And we can mess up as many times as we want to mess up on both of them. And eventually it'll still do the right thing.
Yeah. Okay. Okay.
Now, one additional point, I'm going to have to go pretty soon. This is what I wanted to get through today. We've done the basics of validation here, right? We talked a lot about user experience, making sure that you give them good error messages, how you can trace errors in your own code. One other thing here is, you see how we have a while true and the break and the continue?
Yes.
That's one way to keep doing it. However, another way that you might see is someone might have a variable, they'll call it like num1 valid equals something like this, okay? And then they'll say while not num1 valid. So they'll say as long as number one is not valid, as long as this variable is false, is what this loop is saying here. Or doesn't like that. Oh, sorry. That's C#. Well, not num1 valid, right? Then what they'll do here after this is they'll say num1 valid equals true, right?
Yeah.
And they don't use the break and the continue. I just did the first way that I thought of, but this might arguably be better because it's kind of more explicit, right? You see how this is kind of like more descriptive of what we're waiting on, right? Like before, you just have a while true and a break and continue. This does essentially the same thing. In fact, I'll even show you to convince you that when we run this, if we do subtract, right? Anytime we press something that's not a number, it keeps going until we get a number, and then it goes to number 2. That's what we want. So that's what this code just did. And then, you know, we have the other way that does the same thing too, until we get both, and then we subtract. So both of these do the same thing. They're just alternative ways of writing. And in fact, now that I've thought of it, I would actually probably go with this way because, like I said, it's clearer. Because we're explicitly saying what is the condition of our iteration? You know, when do we stop looping? Basically, we stop looping once number one is true. Or we keep iterating while number one is not valid, right? So I'm going to leave both here in the code. Make sure you can understand how both of these implementations are working. But if I were in a production environment, this is probably the one that I would use because it's more readable code, right? Because when someone looks at this, they say, well, wait, why are we doing an infinite loop? And oh, okay, I see. Once we get it, we're going to break. But this kind of tells them that, right? Says, okay, so we have a variable called num1 valid, and we set it equal to false, right? Because we haven't gotten it from the user yet. And we're going to keep going as long as the number they give us isn't valid. You know, like I think it's just easier to see right from the outset what it's doing. All right, so do you want to see if you can implement the same thing for add here with the two numbers?
Yeah, I'd like to.
Okay, so I'll leave that for you. Something else that we'll do at some point here, maybe we'll implement multiply and divide as well, and then you'll see that this function will be really long, right? Because you already
Yes.
see it's getting pretty long. So it starts on line 585, and then where do we end? Like 639. So almost 100 lines now, right?
Yes. I was wondering if it would make sense to break it up into different functions, one for each of the operations.
Mm-hmm. So we're already doing the actual addition in a separate function, right? But
yes,
if you were to split this function, where do you think you would split it?
I would probably split it into add and subtract.
Mm-hmm. That's what I would do as well, right? And then you have the main loop here in this function where you're getting input, this one, while user input is not equal to exit. And then every time they do something, you call a helper function. And that will keep the length of the main function, pretty small, only as long as it takes to switch between categories. And if you remember, when I first introduced that idea of you only want functions to be about a screen's height, right? I said that there was one exception to that. And that exception is if you have a big dumb switch statement or an if, elif, and all they're doing is like multiplexing between things. So if this is the conditional, do this, if this is the conditional, do this, or whatever, that's exactly where we would be here. Because let's say we have, add, subtract, multiply, divide, exponentiate, or whatever. Maybe you have enough cases, and suddenly this program that we're writing, the external loop where you say if input is equal to subtract, do this. If input's equal to multiply, do this. Maybe that ends up a little bit longer than a screen, but it's really easy code is the thing, right? Like it doesn't make anything more complex by being longer. Whereas this kind of length, this kind of complexity is bad. Like you see how many nesting levels we have here? We're inside the function. Now we're inside a loop. Now we're inside an if statement. Now down here, we're inside another loop. Now we're inside a try. Yeah, do you see what I'm saying? Like how many levels? 1, 2, 3, 4, 5. That's really hard to understand, right? Like where you are is really hard to keep straight in your head. That is really what you want to avoid more than just overall length. The reason why people use overall length as a good proxy is because the two things are pretty correlated, right? If you properly break things down in your head and you use that fancy programming word that we've talked about called encapsulation, where you build functions that do one thing and one thing only, and you split them up so that the functions call other functions. Your code reads a little bit more like English. So like if the user inputs this, then do like add the numbers or something, right? If you call your function add numbers, it might look something like if user input equals add numbers, right? That is pretty easy to understand, right? Certainly much easier than if user input equals subtract. Bleh. What this code is doing, like conceptually, is subtracting the two numbers, right? But in the process of subtracting them, we have to validate that the number they give us is valid, right? And so we'll work on, after we write the whole thing, I tell you, we had this programming project in my introductory to programming class where we could not use loops. They specifically said we could not use loops. And we had to write the entire game of Hangman without using a loop. Just think about that for a second. It was like 400 lines long or something. It was awful. And then we all begged and pleaded and said, please let us use loops. I never want to program without loops again. And we had to write it in one function too. And the goal of this project was to instill in us a burning hatred for not breaking our code down, for doing everything in one file, like one function. Because after that, it was terrible. If you got an error, you had no idea where you were in your code because you had like, 250 lines altogether. And you didn't know, like, you might get an error down somewhere else because you set a variable up higher. You had like 50 variables in your local scope. Like, it was just really hard to track what was going on.
Sounds like a nightmare.
And the reason why they did this, like I said, I actually, now that I look back on it, there were some good parts of learning programming in college. This was one of them. professor was clever. He made us do it this way so that ever after we would hate it with a burning hatred. We'd never do it again. We would always be like, man, why is your function 50 lines long? You should split that. Because we knew exactly what it was like when you didn't do that.
Yeah.
So
makes sense.
Hopefully a little bit of review for you. You know, like I said, anytime things get long and complex, you probably want to think about breaking it down so that your functions are dumb, so that they only do one thing. The more dumb functions you have, then you never have to understand any complicated functions, right? Just think about that for a second. If you only write dumb functions and you build things from compositions of dumb functions, you never have to actually read or understand anything complicated. That's exactly what we want to be doing as programmers. We want to break down the problem, encapsulate the complexity into little bits and pieces so that each thing does just one thing. And then if you've ever seen people write out flowcharts with algorithms, remember that website that I shared, the Code to Flow website that lets you make flowcharts?
Yes.
Pseudocode is great for this. It lets you split things down into basically like the actual conceptual blocks of the code, right? So if this happens, then I want to do this thing. Well, do this thing might be composed of multiple statements. It might itself be a block. But if you view it as one thing, then that's useful for the purpose of figuring out what you need to do. So maybe I'll add something here. You know, I could keep going, of course. Something before I kind of stop doing these things in the morning and kind of send you off to go practice on your own for a little bit. Maybe I'll talk about pseudocode a little bit as well. I actually am not particularly in favor of making people do it. You know what? In this process, let me do development as well. We haven't done unit tests yet, but these things are kind of related. If you set up a framework where you say you have to do things this way, sometimes people's minds work a little bit differently. And so some people like to pseudocode out the entire thing that they're going to write before they even write a line of code. They want to know basically how's the logic going to flow. Some people just they just wing it. They say, you know what, I'll figure it out as I go. I actually am kind of the second kind. If something is complicated enough, I'll sit there and I'll like write a few lines of pseudocode, but I don't think I have ever sat there in my job, even for some of the complicated stuff I've written, and like pseudocoded out the entire thing. Because I'm like, if I'm going to code it, I might as well actually code it. See what I'm saying? Yeah. And by the time I figured out how to do the thing in pseudocode, I could have just written the code itself, like by and large. I mean, I'm being a little bit generalizing. I don't want to like diss it too much. Some people find it very helpful. Like I said, some people like to plan. They like to have that big picture in their head before they write any code whatsoever. I've just always been the sort of person that I don't want to say I just get it right the first time. That sounds really arrogant. But I actually find that I tend to actually like to figure things out as I go, because I just feel like I waste time if I sit there and I don't actually write it in a programming language, because I don't know. That's just me.
My feeling would be that the pseudocoding would probably be useful when you run into a snag and you need to, work something out.
And it's not that I never do it either. Like I said, usually, but my pseudocoding only extends for like a few lines, maybe one or two segments of the loop where I try to figure out, okay, what do I do next, right? Rather than being like the entire thing all at once.
That sounds more like something I would do. Yeah.
The other reason why, and I'm not trying to diss this, like I said, this is really, I don't say it's just personal choice. There's pros and cons to both approaches. Kind of depends how your mind works a little bit. Different people do different things. The other big disadvantage to not coding, like coding it all out from the beginning, is that if you pseudocode, you have no way to test if what you're doing is right or if it's wrong. You might spend all that time writing out this beautiful pseudocode only to realize that it won't even work, right? Whereas the advantage of actually figuring things out as you go along code-wise is that you can, well, if something doesn't work, you can use the debugger to figure out why it doesn't work, right? And so it's more, I don't want to say dynamic, resilient to problems, things like that. Now, the reason why I'm going to bring up test-driven development right after this is because there's a form of programming where unit tests or something we'll get to eventually. But where you're supposed to write your test before you even write any code. And in this case, it's not that that approach does better with pseudocoding, but you need to know what your code's supposed to do. And it helps you kind of write code to a standard. You need to break out your functions before you write anything. And so I think people who have a habit of pseudocoding everything before they write anything have an easier time with test-driven development than people like me. We'll see. This is actually an active point of conversation in my workplace. Our tech lead wants us to do test-driven development. TDD is what all the developers call it. And there's pain and suffering involved. And there's some pushback from like most of the people on my team. There's like 12 of us as devs, and we're split into 3 sub-teams. I lead one of the sub-teams. And our tech lead's trying to get us to do it, but many of us like haven't done it. We're used to the way we do things. Thank you very much. And it may take some convincing here, because it fundamentally changes how you think about programming, fundamentally changes how you go about writing it. Because if you have to know exactly how you're going to split up your functions and what each one's going to do before you write anything, I mean, that's different, right? Than kind of writing one function and then, oh, it looks like I need to make another function here. Let me write that, right? Those are 2 different approaches. Let me use an analogy here before I sign off. My little sister was, at least when she was younger, early teen, she was really into writing. Like she did that National Novel Writing Month thing. And I mean, like wrote 100,000 words or something. And in the novel writing community, there's 2 kinds of people. They call them planners, who plan everything. That's equivalent to the guys who pseudocode everything out. And then the other kind, this one always makes me laugh. They call them pantsers, like P-A-N-T-S-E-R, because they fly by the seat of their pants. And so those are the 2 kinds of people, the planners and the pantsers. And I feel like people code in more or less the same way. There's the planners who pseudocode everything, and then there's the pantsers who figure it out and fly by the seat of their pants. I'm 100% a pantser. And so trying to be open in that. And then there was a group of people, this is their community being clever. They called them plantsters, which both planned and flew by the seat of their pants. And so they planned some, and then they just winged some as well. That's probably the safest balance, right? But you'll figure this out as you go along. And one thing that our team is kind of hyper resistant to, you have to be careful, because there are some times where one way is actually objectively superior to another. And if you're never willing to change, if you're never willing to learn new things, well, you're just going to be missing out on the way that's objectively better, right? Sometimes that's true. Sometimes it really is developer preference, though. And if you start trying to tell your software devs, hey, you have to do it this way because I said so, you may find that software devs leave to find another job. Because if you impose arbitrary rules that don't really deal that much with code quality, and you say you have to do it my way or the highway, well, people can vote with their feet. That won't always be popular either, because sometimes people's minds really do work differently. What works better for one person doesn't work as well for another. This isn't to say that programming's all relativistic and stuff, because it's not. Either it works or it doesn't. But I'm talking about like process-wise. What works better for some people process-wise may not be the best for the others. So you'll get a feel for more of all this. I'm sorry to ramble here. If you ever get on a programming team, you'll see that people are different. And where this causes the most problems is if Johnny writes code one way and Bobby writes code another way, and they can't understand each other's code, because you have to peer review other people's code. And eventually your code's going to be going into the same code base. And so it helps if at least the code that comes out of you is similar enough that you guys can understand each other's. Past a certain point, you'll see that once you've developed programming sense, you'll be able to, what's the right word? Like, even if it's not how you would do it, you'll be able to read it and understand it, if that makes sense. You'll get the spidey sense. All right, so I'll stop rambling. I gotta go to work. And hope this was helpful. You can try to implement the validation here with the try and the catch for addition, so that we can go work on breaking things down, perhaps when we next do it. Or if you don't get to it, that's fine too. So we will pick up then.
All right. Thank you.